Good morning. This is number 16. I believe some people had a couple of questions about it on the worksheet. Okay, looks like a real complicated because we've got a series component, we've got parallel component, but then we got a series component and a parallel component inside a parallel leg. And same thing on the bottom. So this causes some confusion. First of all, we've got to actually find an equivalent resistance somehow. So we've got to reduce this into a form that we can actually see it, okay? So the form that we're looking at is if we took this little excerpt right here, these two parallel components act the same as, if I do the calculation, 1 over 24 plus 1 over 8 is the same as a 6 ohm resistor. So we can reduce it down to this series component. So this section right here is right here, okay? So we have a 3 and a 6 on that leg, but it's a 3 and a 24 and an 8 in that configuration. But we have to make it simpler. So what does 24 and 8 look like together? 1 over 24 plus 1 over 8 is 4 over 24, which is 1 over 6. So it acts just like a 6 ohm resistor. Now on the bottom of that, we have a 10 and a 15 in parallel, and we have a series. So we have to make this reduced to where we can actually see it the same way also. So 1 over 10 plus 1 over 15, 1 over 10 plus 1 over 15 is 3 over 30 plus 2 over 30, 5 over 30, which equals 1 over 6. So that 10 ohm resistor and the 15 ohm resistor act as a single series 6 ohm resistor. So that's where I got this 6 and this 6. So this is a reduced version. This is just a parallel leg with series components on each leg, okay? Now it sounds complicated, but now this is what we have to do. So we know that our series rule says 3 plus 6 is 9, and this is 6 plus 6 is 12. So I can do equivalent resistance for this leg also. 1 over 9 plus 1 over 12 equals, common denominator is 36, 4 over 36 plus 3 over 36 is 7 over 36, and if we want to be exactly right, it's 36 divided by 7, which is 5.14. So that is the equivalent resistance for this leg, okay? So all of this right here reduces down to a resistance of 5.1 ohms. Now, this simplified by doing this is simplified by doing this. So all of these components all together is a 5.14 ohm resistor, okay? So now series, everything we start off trying to make it series because series is the most simple. So this looks like a simple series circuit, and it is, but it's really this and really this when you expand it. So our series rule says that resistance is R1 plus R2 plus R3, so this is 5 plus 5.14 plus 3. So we have a total resistance of 13.14. Now don't get lost because high resistance in the form I equals V over R, a big resistance is a small current, okay? And a small resistance is a big current. So they're inversely proportional, so don't let this small piece of the puzzle, that means there's a lot of current going through there, okay? So once we have that, we can actually go on to the next big piece of the puzzle. So we know that 3 amps from our the first thing that was given is that this had 3 amps going through it, and this had 3 amps going through it. And we know that if it's a series circuit, that 3 amps is what's going to be going throughout. You do not lose your current. So what that means is we have to figure out how much of that 3 goes here, how much of that 3 goes here. And then we've got to figure out how much of this part goes here and how much of this part goes here. And this is how we're going to do it. So first of all, to get the voltage from the battery that you're getting, I got to go V equals I times R. So I know right now that this had 3 amps. And this had, the 5 ohm resistor had 3 amps. Okay? Because they were the only two series components. So that means there's 3 amps of current coming from the battery. So, if I know this is 3 amps and this is 3 amps, V equals I times R. So I know there's 9 volts of drop right here. So it goes from 39.4 to 30.4 from our perspective, conventional flow. Okay? Next, we have 5 ohm resistor and 3 amps. So that's 15 volts a drop. So over here, we drop 15 volts. So if we have 39.4 and we lose 9 here and 15 here, that means all this other components, that means these legs get 15.4 volts, okay? So the entire leg gets 15.4 volts, okay? So, as you look at this component is a series component no matter how you look at it, okay? This component, this resistor, is a series component on a parallel leg, okay? So it's parallel, then series. This is parallel, 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 and then we have a parallel series, okay? You have to take care of the series components first, okay? So we know that in this instance right here, that each leg gets 15.4 volts if we look over. So the total current for each leg, we get 15.4 volts go to here, and there was 9 ohms of resistance, so we know the current is I equals V over R, 15.4 over 9 equals 1.71. So there is 1.71 amps that goes through this leg. Okay, and you can do the subtraction, which is 3 minus that, which is 1.29, go through this leg. So we know it has to add up to 3, okay? And then we know with that right there and that 6 ohm resistor, this is amps and this is the resistor. So find our resistor, 6 ohm resistor, you got 1.29 amps here. So my voltage drop, V equals I times R, 1.2 times 6 is gonna give me a voltage drop here, okay? Then I can do the same thing for my other series resistor. I had 1.71 amps, okay? So the voltage drop, V equals I times R, 1.71 amps times 3, okay? So this is the current that you should have got on the simple ones. I'm sorry, the voltage drop. So this should drop 5.13. This should drop 10.01, 10.01, 7.7, 7.7, 7.7, okay? And I believe you can do the rest of that. All I need is 2 pieces of puzzle to find the third, I equals V over R, and the actual P equals V times I. So you can actually finish the rest of that, alrighty? That is number 16. That is the most complex one that you're going to have to deal with.